Cool. All right, man. So in this one, we're going to look at the negative angle identities. All right, so we already saw the co-function identities, at least a few of them anyway. By the way, these identities, they're some people try to memorize them, and you can if you want to. There are some identities where, like the double angle identities and half angle identities, where you might want to memorize them. But there's so many. I would just take your sweet time, have them written down somewhere so that way you can go back and refer to them. Identities, in my opinion, are they're something that's true, but it's better to think of them just in terms of relationships. They show certain relationships, and it helps me anyway to think of them graphically, which is what I'm going to try to get to later. All right. So let's look at the negative angle identities. So they're giving us sine of some negative angle, and we're going to simplify that. All right. For instance, sine of negative 60. Okay. So if I were to look at sine of negative 60, so from 0, I would rotate downwards 60 degrees. All right. I would get this for my answer. Whatever that y value there would be my answer. And it looks like that's going to be root 3 over 2, but it's in that fourth quadrant, so it's going to be negative. Now, if I were to have rotated upwards instead, all right, if I were to have rotated positive 60, I would have gotten positive root 3 over 2. All right? So here I got negative root 3 over 2. But if I were to have rotated the other way, I would have gotten positive. It's really just these y values is all we care about, right? And if I were to have rotated up 10 degrees, I would have some y value there. Not sure what it would be, but it would be the same y value as if I had rotated downwards 10 degrees. All right? Whatever this y value is would be the same as that y value, but it would just be off by negative. And that even works for bigger angles. Let's say I rotated 120 degrees. So if I rotate 120, I'm going to be up in this neighborhood somewhere. Well, if I were to rotate negative 120, I'd be back down here somewhere. And they have the exact same y value, but they differ by a negative, right? And that's actually the identity for sine of negative x. It's the same as sine of x, but you just have to add a negative to it. So sine of negative x is negative sine of x. Okay. If I reach back over here, and this is why I had these. All right. I was wanting to kind of illustrate why it works graphically as well. So we saw on this little unit circle, whether we rotate, upward or downward, the y value is the same, but they just differ by a positive or negative. But graphically, it would be like whether you go right or left. So if you asked me to evaluate sine of, say, pi over 2, sine of pi over 2, I would go to the right pi over 2 units, and then I would follow that upwards until I get on my graph. So I would get 1. But instead, if you were to ask me to evaluate, here, let me write it out actually. Sine of pi over 2. So sine of pi over 2 would tell me to go over to the right on pi over 2. But if you were to ask me to evaluate sine of negative pi over 2, I would do the same thing, except I would go to the left. I would go left to negative pi over 2, and then follow that downwards. Right? So I'd follow that downwards, and I'd get negative 1. And that's what happens. All right? No matter what angle that you choose to go out on, if I go out the same distance, This is like rotating counterclockwise over here, and this is like rotating clockwise. Rotating clockwise is a negative angle. So as I go out, my y values are the same. So right here at pi, I get 0 on both. If I go out to 3 pi over 2 here, and I go the same distance but negative over there, one's positive, one's negative. All right, that's how it works for sine of x. Give me 1 second. I'll draw my unit circle again. Okay, so for cosine, it's real similar. All right, so if you were asking me to find, say, I don't know, let's say I was looking at cosine of whatever this angle is. It's a positive angle. It's about 30 degrees. So that would be root 3 over 2 is where I would end up. But instead, so this is what we would call theta. Instead, if I rotated negative theta, I'd be going downwards. All right, this would be negative theta. So for sine, it was the y values, and they were off by a negative. But for cosine, it's your x values. And these points actually have the exact same x value. They're both positive. All right. So whether you rotate 30 degrees, or let's say you rotated an obtuse angle. Let's say I rotated to negative 130 right here. Or sorry, that would be positive 130, wouldn't it? That'd be a 130 degree rotation. But if I rotated negative 130, I'd be down in this neighborhood. All right, negative 130. And you can see here, they have the y values are off by a positive and negative, but the x values are identical. They are both negative. All right. So whereas sine differs, the answers will differ by a negative. Cosine, you actually get the exact same answer. All right. So if you rotate 130 this way and take a snapshot of the x value, or if you rotate 130 degrees this way, the x values here and here are the same. And that's our answer, is the x values are the same. So for cosine of negative x, the identity is simply cosine of x. Okay. Whether you rotate upwards or downwards, you wind up at the same spot x value-wise. So cosine of negative 135, that's going to be equal to cosine of 135, which means it's going to be up here in this neighborhood. I think that's going to be negative root 2 over 2. That would be your answer there. As it relates to our graph, all right. So cosine of a negative angle is going to equal cosine of that same angle in the positive direction. So again, as I spread out, whether I plug in pi or whether I plug in negative pi, my answer is the same. It's negative 1 on both. If I were to plug in 3 pi over 2, I get 0. If I were to plug in negative 3 pi over 2, I get 0. Cosine of x and cosine of negative x give me the same answer. All right. So we can use that to simplify negative angle expressions. All right. So next time I ask you about cosine of negative 270, you need to say, Mr. West, I don't want to do cosine of negative 270. That's hard to think about. I'm going to do cosine of 270. It's probably easier actually to think of this one, but anyway, that's the idea. We're going to use this in conjunction with our cofunctions next.